So our objective here, this is it. Enthalpy of formation is something new. We're going to go over that, and we want to say enthalpy is a change in energy in heat energy, uh, and we want to know, is it exo or endothermic, and that's what we're trying to predict or estimate. And the estimate there is because you really have to measure these things experimentally to actually quantify them. All right, this is that F means formation. This sub naught means it's at like standard states, or uh, 1 atmosphere and 25 degrees Celsius, right? These are basically the same name for or different names for the same thing. Now, what this actually is how much energy, the enthalpy change, when I make 1 mole of a compound. And it comes from this, all right? And like I had said, you have to do this in a lab. So these values, which you're not going to be expected to know, you can see them listed. And in the back of our text, or any text, there's going to be lots of them. They're measured experimentally, all right? So here's what happens. Take water, all right? What's its enthalpy of formation? Well, what's water from? It comes from oxygen and hydrogen gas. Elementally, in their standard states, they're gases. So they would do this in a calorimetry, and then they're going to get a value, right? There's the value. And the only thing is, it would be for 1 mole. So you'd have to write. You don't actually write the balanced equation. Typically, you see fractions. All right. Now, this is important. The reason we're going over these is they're going to help us find the enthalpy of reactions. And let's look at that. But before, sorry, I got a little bit ahead of myself. What this means is this negative just is that when these things are in a standard state, they don't have their change in enthalpy is 0, because that's what we set it as a baseline, and they lose energy to become water. So water is actually more stable than these things at their elemental state. Okay, that's what that means. All right, now let's use this to figure out our enthalpy of reaction. Sometimes you're going to see it with this, sometimes you won't. All right, RxN means reaction, but it's not always written. Here's our formula for it. These are the like italicized F's. This formula is right there. All right. You can see there's a similar one for Gibbs free energy and entropy. But this is the formula we're going to use. It's similar to the one about bond energy. However, you've got a negative here, where you're not a negative. Well, it is a negative, but you're minusing your reactants. All right. Let's look at the steps, and then look at some examples. Our steps: you need a balanced equation. You find your values, and you just have to remember you're going to be multiplying your coefficients by your value, because all of the values are for 1 mole. Here's an example. This is the combustion of propane. Not propane, pentane. Pentane's found in gasoline. All right. First thing I do is the equation of balance. It is balanced. All right. I'm going to look up my values. Here they are. All right. And then the next thing is I'm going to sum them up and remember to multiply my coefficients. Now you'll notice oxygen is 0. That's because oxygen at its standard state is 0. And this is its standard state. It's a gas at room temperature, or 25 degrees Celsius at 1 atm. Here's my formula. All right. And then I'm going to write out this long equation. I'm going to multiply 5 times this. It's going to be 5 times that. All right. 6 times that. And then I'm going to minus that, because that's my reactant. And that's my reactant, and I minus the reactants. All right. Therefore, this should be a negative number. I get these two products, and I get that. Add it all up, and that's what I get for my enthalpy of reaction. All right, let's do one more example. Here's my enthalpy, here's my reaction. That's H2 gas and that's C2H4 gas. All right, so ethene to ethane. Double bond, now it has all single bonds. So first thing I do is the equation balance. It is, and I'm going to look up my enthalpy values. They're going to be in a text or they'll be provided for you. Here they are. You'll notice this time that my reactants are positive and my products are negative. So this is going to have a negative. It's going to be exothermic. I'm going to multiply my coefficients. They're all 1, so these values will stay the same. All right. And I'm essentially going to add these two numbers, and then I'm going to round for sig figs, and that's my answer. All right. I hope this has been helpful, and let me know what I can do to help. All right. Bye.